So today we're going to talk about absolute value and what that means and what does it mean when we have equations that contain absolute value, how can we solve those, and so forth. So as a definition, absolute value is the distance that a number is away from zero on the number line. That's the actual definition for absolute value. Another thought that you could kind of associate with absolute value is it's the strength of a number or the magnitude of a number. I kind of like the strength of a number, and I actually will, if you show somebody how strong you are, we do this with Ellie all the time, show me how strong you are, and she goes like this and shows her muscles and so forth. When you put your arms up like that, and surround yourself with these vertical lines, that's the symbol for absolute value as well. It's two straight vertical lines. So, if that helps you to remember a little bit what absolute value kind of means, go for it. Most of you probably have learned something about absolute value around the fact of make it positive, or it's positive, it's always positive, or something like that. And that's because distances are given to us as positive numbers. The distance away from zero is positive. So the absolute value of 8 means how far away is 8 from 0 on the number line? That's 8. 8 chunks, 8 steps, 8 units. What about negative 3? How far away is that from 0? 3 steps. 3 steps left instead of right, but 3 steps. What about 3? The absolute value of 3? That's also 3 steps away. So that's kind of important. The absolute value of 8 is 3, the absolute value of negative 3 is 3, and the absolute value of 3 is 3. And this part is intriguing to me, that there are two numbers that are the same distance away from 0. They both have absolute values of 3. And this is really at the heart of why when we solve equations later today that have absolute values in them, there's going to be 2 answers, because there'll be 2 different numbers that'll be the same distance away, or that's at the heart of this. So it's not always this simple, but so when we have equations that have absolute value bars in them, that usually means that there's going to be 2 different solutions. Like I said, there'll be 2 different numbers that are the same distance away from 0, one to the left and one to the right. And let's go through a couple of examples here. The first example equation here, the absolute value of x is 4. What that's saying is, give me a number so that the absolute value of that number is 4. And there are 2 different numbers that'll work here. You got one? Negative 4 is 1. Because the absolute value of negative 4 is 4. It's 4 chunks away. Here's negative 4 on the number line. Here's 0. That's 4 steps away. And then in the other direction, 4 is a solution. So x could be either 4 or negative 4. Now, in our other example, x plus 3 equals 5, I need to come up with 2 different numbers that make this true. 2 is one that you guys think of right away, because when I plug in a 2, 2 plus 3 is 5, and 5, of course, is 5 units away from 0. So, what's the other number? Negative 2? Do you think negative 2 works? A lot of people guess negative 2, because in the last problem it was 4 and negative 4. Why wouldn't it be 2 and negative 2? The reason it's not negative 2 is if I plug in a negative 2, negative 2 plus 3 is 1, and the absolute value of 1 is 1, not 5. So I need that chunk in the absolute value. That chunk in the absolute value has to be negative 5. And so, in order for that chunk in the middle to be negative 5, x has to be a really big negative number. You said 8, negative 8. Let's try that one. I think you're right. So, negative 8 plus 3 is negative 5, and yeah, the absolute value of negative 5 is 5. So the two answers for this problem are the 2 that you came up with right away, and the negative 8, which was not obvious, but after a little bit of reasoning, we could figure that out. Now, what I hope to do next is show you how to find these numbers more quickly. Usually one of the numbers you'll be able to find relatively quickly, but that other one is not always so simple. So here's the strategy. If you want to solve an equation with absolute values, here's some thoughts, some guidelines that should help in most cases. Do some moves, if you need to get the absolute value alone on one side. In our first example there, 2x plus 4 equals 12, the absolute value is already alone, so we don't have to do anything. But in the problem below it, 3 plus absolute value stuff, I'm going to want to first get the absolute value alone. Once it's alone, then we're going to split it up into two different equations, a positive case and a negative case. That's new, probably, for most of you. So we're going to have to solve two equations with different numbers. And that's step 3, is just solve each one of those situations separately. So let me zoom in on this guy. 2x plus 4 equals 12. The first step is to try to get an absolute value alone, and I told you that for this problem that's already done. I've already got absolute value of 2x plus 4 all by itself on the left-hand side. So now comes step 2, which is the splitting this up step. I need that stuff in the absolute value to be 12, and I need that stuff to be negative 12. So I'm going to write both of those down. 2x plus 4 has to equal 12, and 2x plus 4 has to equal negative 12. That's the splitting up into positive and negatives. Step 3 then is to solve those independently. So let's solve the positive case, and to do that we're going to have to try to get x alone. It's been multiplied, it's been added to, so I'll subtract 4 from both sides. That gives me 2x's and 8. And to undo multiplying, divide. And so we've got x equals 4 as one solution. And I want to warn you, the second answer is not negative 4. It is not that simple. You cannot just say 4 and negative 4. That's true for only the very first example in your homework tonight, where it's that short. Maybe the second problem too. To solve the negative case, we're going to do the exact same moves, but the only difference is that instead of a negative 12 or a positive 12, we're starting with a negative 12, which means our numbers are going to be different when we're done. So I will subtract 4 from both sides again. And here, negative 12 minus 4 more is a really big negative 16. And 2x equals negative 16. And again, we'll divide by 2 to get x alone. And we get negative 8. And so the two answers to this problem, 4 and negative 8. And you can always check if these are solutions by going back to the original problem and plugging them in. If I plug in a 4, 2 times 4 is 8. 8 plus 4 is 12. And of course, the absolute value of 12 is 12. The other one might be a little more challenging. When we plug in a negative 8, 2 times negative 8 is negative 16. Negative 16 plus 4 is negative 12. And the absolute value of negative 12 is also 12. So yes, those are both solutions. Let's look at a different example. This one is a little bit harder because the absolute value is not alone to begin with. Some of you might be tempted to split this up right away, and the last couple problems in your homework will look like this. The absolute value will have some extra stuff attached to it. If you split it up right now, you'll end up getting one answer right and the negative case wrong. So before we can split this up into a positive and a negative version, I need to first get rid of that plus 3, or 3 plus. How do I do that? Yeah, minus 3 from both sides. That gives us absolute value of x plus 4 equals 8. Now this is similar to the last problem where I've got the absolute value alone. Now is when we're going to split this up into a positive case where x plus 4 equals 8, and a negative case where x plus 4 equals negative 8. And we do the same move to solve both of these. They both have a 4 added to them, so we need to undo that by subtraction. Subtracting 4 from both sides of the positive case gives us x equals 4 is one potential answer. And subtracting 4 from both sides of the negative case gives us negative 12 is a different answer. Again, both of those you could check if you went and plugged them in for x. Few other examples, same steps. We're going to try to get absolute value alone, and then we're going to split it up and solve for it. So this example, 7 minus 2x equals 5. The absolute value is already alone, and so we can jump straight to the splitting up step. The stuff inside the absolute value, in one case, equals 5. And in the other case, equals negative 5. Notice I don't have absolute value bars anymore. As soon as you split it up, that's how you get rid of absolute value bars. They go away. We don't write them anymore. And now we're going to do the same moves to these equations to solve them. And so I might recommend let's get rid of the 7 a second. And then I'll have a minus 2 multiplier to divide out. But to get rid of the 7, we'll subtract 7 from both sides of the positive case. And sometimes I find it efficient to work with the negative case at the same time. So since you are going to be doing the same moves with each, kind of saves you the decision-making process. 7 minus 7 is nothing, and I'm left with minus 2x. 5 minus 7 is negative 2. In the negative case, the 7's still go away. I still have minus 2x. Negative 5 minus 7 is negative 12. Then what move undoes the multiplying? Divide by negative 2. And you'll do that on both sides of the positive case. And we'll divide by negative 2 on both sides of the negative case. So this gives me x, and the negative 2 divided by negative 2 is a positive 1. On the right-hand side, I still have an x, and negative 12 divided by negative 2 is a positive 6. And these two numbers, 1 and 6, are your solutions. And I included this lesson, or this particular example on purpose because I wanted you to notice I got two positive numbers out. It's possible that for an absolute value problem, you end up with two positive answers. It's possible that you end up with two negatives. It's possible that you end up with one positive and one negative. It's possible that one's a fraction and one's a decimal. One's a fraction and one's an integer. A nice answer. Or they might both be fractions, or they might both be integers. So don't assume anything about the way the answers are going to look necessarily, because there's lots of different situations that can occur depending on what's given to you. So again, both of these numbers work, and if you test them, that is, if you plug in a 1, 7 minus 2 times 1, that's 7 minus 2 is 5. Its absolute value is 5. And if you plug in a 6, 7 minus 12 is negative 5, and the absolute value of negative 5 is 5. They both work. That's the ultimate test to see is it true or not. the last example we have, x plus 3 equals -5. This is actually a trick question. I don't know if on your homework you'll see any like this, but remember, absolute values always give positive things. And so no matter what this is, no matter what that chunk is, when you take its absolute value, it's always going to end up being something positive. Can something positive ever equal -5? No. So, no matter what x is, this will always be false. So, the way we would answer this is that there is no solution. You could write that it's a contradiction if you want, if you remember that from our equation unit earlier in the year. But this one has no answer. And again, I'd be on the lookout for these sort of things. If I were a textbook writer, I'd probably include 1 or 2 tricks like this in there just to annoy students and make their teachers feel powered and so forth. So anyway, that's absolute value.